On solving compound inequalities. So a compound inequality consists of two inequalities joined by the words and or by the word or. So solutions to a compound inequality contains the word and must be the values that make both of the inequalities true at the same time. In other words, the solution must appear on both individual graphs. This is known as the intersection of the graphs. So for and inequalities, we are looking for the intersection where both inequalities are true. So going about solving these, starting with number one, you will see that we have two inequalities with and in between. So essentially what we'll want to do is solve both inequalities separately and then graph them both on the same line. So starting with my left inequality, I'm going to start by adding 2 to both sides, isolate my variable. This will leave me with 3 halves x is less than 9. Now to undo my fraction, I'm going to multiply by the reciprocal. So I'm going to multiply both sides by 2/3. Just flip my fraction. And I'm going to make this 9/1. So my reciprocal on my left side is going to cancel, leaving me with x is less than 9 times 2, which is 18, 1 times 3, which is 3. And now we have 18/3, which is just 6. So my first inequality gives me x is less than 6. In my second inequality, this one's a little simpler. All we need to do is subtract 10 from both sides, and that will give me x is greater than 4, which is my second inequality. So what I typically do is I will graph this on the same graph. So making my number line here, I will put both 4 and 6 on my number line. For x is less than 6, that'll be my blue graph. So I have just less than, so I'll use an open circle, and I am going to shade to the left. With x is greater than 4, I'll make that my red graph. I'm going to have an open circle at 4, and I'm going to shade to the right. So in this case, since I have an and compound inequality, my solution is only where the two overlap. So I am going to highlight the intersection point where they both overlap. You guys can just shade that more darkly if you are working with a pencil. And finally, I could write this in compound inequality form where I have 4 as my left end, which x is greater than 4 and less than 6, which is just pushing these two together. Okay, similarly, number 2 is another and compound inequality. You will either see and in between, or you will see a compound inequality written as 1. So in this case, you can either do one thing to both sides, or you can break it up. For this first example, we'll break it up. So this really forms two inequalities, which would be my left side. So negative 2 is less than 2x minus 4. And my right side, which is 2x minus 4, is less than or equal to 6. Now I'm going to solve both sides separately. So for my left side here, I'm going to add 4 to both sides. That will give me 2 is less than 2x. Now I'll divide my coefficient to both sides, and that's going to give me 1 is less than x. But like I said before, typically we like to graph with our variable on the left side. So all I'm going to do is flip my inequality to be x is greater than 1. On the other side, same process. Start by adding 4 to both sides. That will give me 2x is less than or equal to 10. Now I'll go ahead and divide my coefficient. X is less than or equal to 5. Once again, I'm going to graph this on the same number line. So I've got both 1 and 5. 1 is going to be graphed with an open circle, shaded to the right. That'll be my blue line. And 5 is going to be a closed circle, shaded to the left. And once again, since this is an and inequality, the solution is where the two overlap. If I wanted to write this up as one inequality, I would have 1x, which is less than or equal to 5. But you wouldn't necessarily have to. Both of these with and in between would be sufficient as well. All right, so those are our and inequalities. Now we'll go on to our or inequalities. Make sure to try the bottom two on your own. So for an or inequality, this is where solutions to compound inequalities containing the word or must be the values that make either of the two inequalities true. In other words, this solution is a combination of both graphs. This is known as the union of the graphs. So essentially, anywhere where either of the two inequalities are true works for an or compound inequality. So same process, we need to solve both separately. Here, since I have x on this side, I'm going to start by subtracting x to get all my variables on the left side. This will give me 2x is greater than or equal to 4. Now I'm going to go ahead and divide my coefficient. This will give me x is greater than or equal to 2. And on the other side, I will do the same. Subtract x from both sides. That will give me negative 3x is greater than 6. Next, I'm going to divide my coefficient. Since my coefficient is negative 3, I'm going to have to go ahead and flip my inequality. This will give me x is now less than 6 divided by negative 3, which is negative 2. The key here is you cannot write your or compound inequalities as one, so you will write the answer as two separate inequalities. Just make sure you have the word or in between. When graphing these, things are just a little bit different. So I'll have my two numbers, negative 2 and 2. I know that x is greater than or equal to 2, so I'll use a solid point, shade to the right. And for my second graph, I have x is less than negative 2, so I'm going to use an open point shaded in the negative direction or the left. So that is one kind of or inequalities that you'll see. The second kind is an example like number 2. Same process, solve both separately. So I'm going to start by subtracting 7 from both sides. This will give me x is greater than negative 2 minus 7. which is negative 9. Or we have our other side, which I could add 4 to both sides. And that's going to give me x is less than 12. So in a case like this, if you were to graph both separately, we have negative 9 and we have 12. X is greater than negative 9. So we'll have an open point shaded to the right. And x is less than 12. So we'll have an open point shaded to the left. But remember, with or inequalities, your solution is anywhere where either of the two inequalities are true. Well, since they're pointing in opposite directions, that means that anywhere on the number line would be a solution. So in a case like this, your final answer would be all real numbers. Or you could write, or you could write infinite solutions. All right, so make sure you guys try 3 and 4 on your own. The thing with or inequalities in particular is there's kind of a couple different variations of solutions that you're going to see. This is not so much the case when it comes to and inequalities, but we'll make sure to go over the other 4 examples together in class. All right, please bring any questions that you have, and thanks for watching.